guys, welcome back to our channel Get Play Soon. In this video, we are going to see how merge sort works, how to implement merge sort in Java, and we're also going to see how to make this unsorted array into sorted array in ascending order using merge sort. So let's get started. Merge sort is a popular comparison-based sorting algorithm that follows divide and conquer approach. So what is divide and conquer approach? It divides the given unsorted array into smaller parts, recursively make it smaller parts, and then merges them back together to obtain the final sorted array. How this works? So basically there are three steps in divide and conquer approach, that is divide, conquer and merge. Divide is a process where the given unsorted array is divided into two halves at each step in this division. The array size is halved at each level of recursion. And the second step is conquer. Conquer is the process of sorting each divided subarray. So divided subarrays are sorted, and the last step is merge. Merge is a process of merging the two sorted subarrays. Two sorted subarrays we keep merging until we get the whole full sorted array. So this is how merge sort works. Let's take an example and look into it how merge sort works clearly. Now here you can see there are 6 elements in this unsorted array. Now the first step is to divide, right? So we divided this unsorted array into two parts of 3 elements each. Take the left subarray and divide it again to another halves. So 38, 52 and 9. So we keep dividing this given unsorted array until we reach one element. So all the elements in the green color in this slide are the single elements. Until all the elements are individual, we keep dividing. This is the first step, dividing. Now let's go to the next step, conquer and merge. So here we have divided elements. So to start with the conquering, let's use the initial pair of elements 38 and 52. Now 38 is less than 52, right? So 38 comes first. So 38 and 52. So we sorted and merged this subarray. Again, next pair of elements 9 and 18. 9 is less, so 9 comes first. 9 and 18. Again we sorted and then merged. Next 6 and 47. 6 is less than 47, so 6 is followed by 47. Now we have 3 sorted subarrays. We are supposed to merge them. Let's take the first two subarrays 38, 52 and 9 and 18. Comparing the first elements of these two sorted subarrays 38 and 9. 9 is less than 38, so 9 comes first. Continuing, since 38 is still larger than 18, we place 18. Now only one sorted subarray is left, 38 and 52 in order, so we place 38 and 52 in order. So 9, 8, 38, 52. This is a sorted subarray. Now we are left with one more subarray, that is 6 and 47. Starting with the first element, since 6 is smaller than 9, so we begin with 6. Then we place 9, followed by 18, 38 and 47. And at last we add 52. This is how merge sort works. So there are 3 steps. Once we divide the whole unsorted array, we conquer, that is we make sorted subparts and then merge the sorted subparts until we reach the whole sorted array. So this is the sorted array in ascending order sorted using merge sort. Now let's see how to implement this in Java. So in the first line here, we are importing the arrays class from the java.util package. It is used to print the sorted array later in the code. Now moving ahead, we have a main function here. In the main function, we are creating an array with these unsorted elements 38, 52, 9, 18, 6 and 47. Now here in the next line, we are passing 3 things to the merge sort function. We are calling the merge sort function using 3 things. One, the array itself. Second, the left index, that is 0. In array, indexing starts from 0. And third is the right index, that is array.length minus 1. Why we are using minus 1? Because index starts from 0, right? So we are passing 3 things, the array itself, the left index and the right index. Once we pass all these things to the merge sort function and we get the result from merge sort function, we will print out the result using this system.out.println. Now let's check this merge sort function. In the merge sort function, as we discussed earlier, there are 3 parameters, the array, left pointer and the right pointer. Now here we have a condition. What is this condition? If left is less than right. This is the start of the condition that checks whether the subarray is more than one element or not. If it is not more than one element, which means there is only one element, there is nothing to sort. So we will not enter this if condition, and if this condition is false, which means there is no element left to sort, the array is sorted. If this condition is true, which means there are more elements in this subarray. We are supposed to enter this if condition and do the merge sort. So in the next line, you can see we are creating a variable middle. What is middle? This variable is used to find the middle index of the array. Usually it is left plus right by 2. To overcome this overflow condition, we find middle using left plus right minus left by 2. Moving ahead, we are making recursive calls to the merge sort. Why are we doing this? As you already know, we discussed in the merge sort we have 3 steps: divide, conquer and merge, right? So for the division process, we have found the middle index. Now we are supposed to divide them. So to divide, we are recursively calling the merge sort function and dividing using the same parameters but with different values. Now we are creating two variables n1 and n2 to calculate the sizes of two subarrays that needs to be merged later. So n1 is middle minus left plus 1 and n2 is equals to right minus middle. Now moving ahead, we are creating two arrays, two temporary arrays, left array and right array, with the sizes n1 and n2 that we have created in the previous steps. Now using all those things that we created above, the n1, n2, the left array and right array, what are we doing here? We are copying elements from the original array to the left array and right array respectively in these two for loops. The first for loop runs from I is equals to 0 to I less than n minus 1. We are copying from the original array and placing into the left array. And the second loop starts from j is equals to 0 to j less than n2, and we are copying elements from the original array, the right side elements, to the right array. This is just the copying part. Now from here the code is very important. Please listen carefully. Here we are creating 3 pointers: I is equals to 0, j is equals to 0, k is equals to left. Here I and j are the indices for iterating through the left array and right array. Okay, and why are we creating k and what is k? K is the index that is used to place the merged elements back to the original array. To track that point, let's create a variable k, and by default let us keep the value as left. Moving ahead, very important while loop. This is something which merges the array. So we have a condition to get into this while loop. What is that condition? I less than n1 and j less than n2. If and if both I less than n1 and j less than n2 are satisfied, then only we enter this loop. This loop means, so what is this condition? This condition says that I and j are within their respective subarrays, respective bounds, which means they are in the left array and right array only. Once we enter this while loop, we have if condition. If the element at left array of I is less than or equal to right array of j, which means the smaller element is in the left array. Then what are we supposed to do if the smaller element is in the left array? We copy that element to the original array and both I and k are incremented. If it is not in the left array, then it must be in the right array, right? So in the else condition, if left array of I is greater than right array of j, which means the smaller element is in the right array, then we copy the element to the original array and both j and k are incremented. I hope you understood this while loop. This is a very important while loop of the whole code. Now, what if the elements are still left in the left array and right array? In case the elements are left in the left array and right array, we have two more loops. That is when I is less than n1 or j is less than n2. If elements are left, we are just copying those elements to the original array, and k and I are incremented if it is left array, and k and j are incremented if it is right array. So this is how we implement merge sort in Java. Maybe it's a little complicated, but if you understood this, if you understood the previous example that we discussed, you might understand. And in case if you have any doubts, feel free to comment below. I'll always be there. So this is how we implement merge sort in Java. Now let's understand the time and space complexity. The time complexity of merge sort is O of n log n. Why? For the division part, where the array is divided into halves recursively again and again, that part takes O of log n times. And for the merging process, after conquering part, we are supposed to merge, right? For the merging process, it takes O of n. Total O of n and O of log n, O of n log n. The time complexity of merge sort in worst case is O of n log n. Now speaking about space complexity. What is space complexity? It is used to determine the space needed for the program to run. Here what are we doing? We are creating two temporary arrays, left array and right array. And the left array and plus right array is equals to the size of original array. So that is O of n space. Additionally, we are doing recursion to divide, right? We are calling the merge sort function again and again. So that is recursion. That recursion takes O of log n space due to maximum depth of recursion. In total, O of n plus log n. That is, in terms of big O notation, we only consider the dominant factor. So the space complexity is O of n. That is it from my side. If you have any doubts, feel free to comment below. If you like this video, please like it and share it with your friends. Please subscribe to our channel. Get placed soon. Thank you so much for watching till the end. Bye bye.